In this video, we're going to continue our work with solving exponential equations. And now we're going to work with exponential equations in which it is not easy to change the two sides of the equation to a common base, such as this first example here. Because we have a base of 3 and a base of 5, there's no common base that unites those two. We are going to use a logarithm. And the reason we're going to do that is we're trying to get this x out of the exponent, and we know that a logarithm function, the outputs are exponents. So when you get something like this, an exponential equation where your variable is in the exponent and you're trying to get that variable out of the exponent, taking the logarithm of both sides of the equation is a really good strategy. Technically, you can use any base, and because we want not only an exact answer for x here, but we also want a decimal representation, we're going to be using our calculator, right? So it's a good idea to use one of these two logarithm bases. We can either use the common log, which is log base 10, as you know, or we can use the natural log, which is log base e. In our book, we tend to use natural log, so that's what I'm going to show here. But again, you can use either base and you will get the same answer for x. So our first step here is going to be to take the natural logarithm of both sides of this equation. So natural log of 3 to the 2x equals natural log of the 5. So again, we've taken the natural log of both sides of the equation, and now we're going to use our properties of logarithms to try to get this x here out of this exponent. So we're going to use the power rule, and you've talked about that in a previous video. And so the power rule allows us to rewrite this logarithm on the left-hand side with this 2x as a coefficient. So let me show you that power rule in case you haven't seen it. Okay, so here are properties of logarithms, and we're using the power rule, which allows us to take the power here, w, and move it to become a coefficient in front of the log. Okay, so we're using that with the 2x. We're going to rewrite that. We're going to rewrite that 2x as a coefficient times the natural log of 3 of the base. And of course, we still have our log of 5 on this side. Okay, now our point here now is to isolate that x. And notice that we have a 2 and a natural log of 3 multiplied times that x. So we're going to divide. We'll be dividing so that we can get this x alone. Let's start by dividing let's just divide all in one step. We're going to divide both sides by 2 times the natural log of 3. 2 times the natural log of 3. And so then notice how on the left-hand side, the 2's reduce and the natural logs of 3 reduce, and you're left with the x. So this is your exact answer. So when they ask for x in exact answer, that's this guy. Now, again, I just want to remind you, natural log of 5 is a number. It's an irrational number. It's a decimal. Okay, natural log of 3, again, is a decimal. These were the exponents on e that got us to 5 and to 3 as answers, right? Okay, so don't get too confused here, but now let's get a decimal approximation to 3 digits. So now you're going to go to your calculator. Natural log 5 divided by, now heads up here. Notice how my denominator here is a product. So I'm going to need a set of parentheses. Otherwise, my answer is going to be off. Okay, so natural log of 3, close the parentheses. So again, really important that you have that set of parentheses here for this product. Okay, and now let's hit enter, and notice we get this decimal irrational number. We expected that, right? And so let's just go to 3 decimal places, and so there's the approximation. Now if you want to check this, I'm going to go ahead and just take that answer that's there, previous answer. I'm going to store it in x in my calculator. Okay, and then I'm going to go 3 raised to the 2 times x, and then hit enter. And see how we get the 5 back out? So yay, we have the right answer. Okay, so that's how you can check that quickly with your calculator. Let's go to the next example. Okay, now we have 3 to the x minus 1 equals 2 to the x. So again, this is an exponential equation because we have our x's in the variables. These are not easily rewritten in common basis. So we're going to use the natural log. We're going to take the natural log of both sides of the equation. So we write natural log of 3 to the x minus 1 equals natural log of 2 to the x. Just like that. And now we're going to use our power rule again to move the exponent here on the 3 in front of the natural log expression. It becomes a coefficient. And bring along with it the parentheses, because the parentheses is important. So x minus 1 times the natural log of 3 equals, and we're going to once again use the power rule, and we'll move this x as coefficient in front of log of 2. Natural log of 2. All right, just like that. Now again, our whole purpose is to solve for x, and we've got x's on two sides here, right? So we're going to have to do a bit of algebra. Here, this natural log of 3 is just a number. Don't let this word, this ln in front of the 3 confuse you. So we can use distributive property. So we're going to distribute. I've got the natural log of 3 here in the back, but I'm just distributing times both of those terms. Okay, so I'm going to have x natural log of 3 minus, and then 1 times natural log of 3 is natural log of 3 equals x times the natural log of 2. Just like that. Again, we've got x term here and an x term there. We need those on the same side of the equal sign. And I'm trying to minimize bunches of negatives. I'm going to bring this term to this side of the equation. I'm going to add this natural log of 3 to move it to that side of the equation. It's like this. Subtract this guy. So we're going to keep this term here, x natural log of 3. Subtract this one to move it to the same side of the equal sign. And then this term that doesn't have an x, we're going to add it so that we can move it to this side of the equal sign. So it looks like that. And then, see those two x's here? We're going to factor those out. So we're going to factor out the x, because again, remember, our whole purpose is that we want to get x alone on one side of the equal sign. So we got to move it to the front. You can probably see where we're going here, because now we're going to divide by this expression. So just divide both sides. I'll keep it in the parentheses, and we do that to both sides like that. So now we have our x here, which is the natural log of 3 over natural log 3 minus natural log of 2. I took it here back into the calculator to get the decimal approximation. Don't forget that we need those parentheses down here below for the denominator. So I'm getting 2.710 approximately. Okay, shall we check it? Now again, I'm going to store my answer in x. Okay, just like that. Then I'm going to come over here and do both sides of this equation. So 3 to the x minus 1. Okay, I get that decimal, and then I'm going to do 2 to the x. And guess what? We get the same decimal on both sides of the equation, so that works. Okay, I hope that helps with these problems.